Welcome to this video lecture on the subject basic electrical and electronic circuits. So in this lecture we are going to discuss about mesh analysis. So what is meant by mesh analysis? It is a circuit analysis technique used to determine the mesh currents in an electrical network. So consists of an electrical circuit. Here mesh is the smallest possible loop. It is a closed loop. It should not contain any other loop inside it. So this mesh can be solved for an mesh current. What is the basic principle? So it is based on Kirchhoff's voltage law. Algebraic sum of voltages around a closed loop is 0. So for in this diagram V1, V2, V3 are the voltages. So sum of all the voltages around the closed loop is 0. We apply this KVL for solving the mesh analysis method. So what are the steps followed in mesh analysis? So for the given circuit diagram, we need to identify the meshes in the circuit. For example, in this circuit, loop 1 and loop 2 are marked with currents I1 and I2. So assign mesh currents I1, I2 in the same direction and we can apply KVL to each mesh. So every equation is written using the KVL. Express the voltages using Ohm's law. So using this, for two meshes we need to form the simultaneous equation, and by solving these two equations we can solve for the currents I1 and I2. So using the mesh currents, branch currents or voltages can be calculated. And for current source given in a single mesh current equals the given source current. Here in this, no KVL equation is needed for the particular mesh. So let's see an example for mesh analysis. So for the given circuit, determine all the branch currents and voltage across the 5 ohm resistor by loop current analysis. So solution for this example is, first of all we need to note down the mesh currents for the given circuit. So for the mesh 1, I1 is noted and mesh 2, I2 is noted. And we need to apply the KVL equation for the loop 1 and loop 2. So for the loop 1 we obtained 14I1 minus 5I2 equal to 50 by using the KVL method, and for the loop 2 we obtained minus 5I1 plus 15I2 equal to minus 25. So these are the two simultaneous equations for the loops. So by solving these two equations we get 37I1 equal to 125. From this I1 equal to 3.378 amperes and I2 is minus 0.54 amperes. So these are the mesh currents. So in question they asked to solve the branch currents. So for the branch AB, the current flowing through the 3 ohm resistance is same as I1. So it is 3.3 ampere. So IAB is 3.3 ampere. And IEB is minus I2. So the direction is opposite of I2. So it is minus I2. So the answer is 0.54 amperes for IEB. And for IBC, there are two currents flowing between BC, that is 5 ohm resistor. So the answer is I1 minus I2. So when get 3.91 amperes. And voltage across the 5 ohm resistor is 5 multiplied by current IBC. So the answer is 19.5 volt. So we have solved two mesh currents I1, I2 and branch currents using the mesh analysis method. Advantages of mesh analysis: it is simple and systematic for voltage source dominated circuits and fewer equations when meshes are limited. It is well suited for manual calculations. And limitations of mesh analysis are, this method is only applicable for planar circuits and it becomes complex with many meshes. Super mesh handling requires extra care. Like it is shown in this diagram, there are 3 meshes in this circuit. So we need to give extra care while solving the equations. Assessment questions. Mesh analysis is primarily based on which of the following laws? So the answer is KVL, Kirchhoff's voltage law, option A. Mesh analysis is generally used to determine which parameter. So it is used to determine the mesh current. So the answer is B. Thank you for listening this lecture.